let's talk about buffer solutions. So we have to look at what is buffer solution, buffer capacity, then formulas in formula to calculate pH of a buffer solution, which is called the Henderson-Hasselbalch equation. There are to solve simple calculation in this video, but in the next video you have to solve complex calculations. So you want to stick to the end of this video and make sure you take down every single thing. So let's get into it. So what is buffer solution? A buffer solution is a solution that resists change in pH when small amount of strong acid or base are added to it. So those solutions that resist the change in pH, that there's no significant change in pH when you add small amount of acid to it. Do you understand? These are called buffer solution. And how can you make a buffer? How can buffer be made? So a buffer, we have two type of buffer, but before moving to buffer here, what is buffer capacity? Now, this is the limit to which a buffer solution can resist change in pH. So please, you have to take these two definitions down because you may likely see them in the exam. What is buffer solution? Then what is buffer capacity? Buffer solution is a solution that can resist change in pH when small amount of acid or base are added to it. Buffer capacity is the extent or is the limit to which a buffer capacity resists change in pH. So there are two definitions here we need to take note of here. So the next one to look at is what type of buffer. So we have types of buffer. Types of buffer. Now we have what called the acidic buffer and we have what called the basic buffer. So here we have acidic buffer was solution. They have what basic buffer solution. So we have to look at them one after the other. So how do you identify acidic buffer? How do you identify what basic buffer? Do you understand? So let's look at what acidic buffer. Acidic buffers. So when we talk about acidic buffer, the word acidic. Now these are buffer solutions that combine the a weak acid and its conjugate base. A weak acid and its what conjugate base. So a buffer solution, acidic buffer solution is made when you combine weak acid plus what conjugate salt or conjugate base. Right there. So for you to create a buffer, which is called the acidic buffer, you need what a weak acid and its conjugate salt. Do you understand? Now, according to Bossler theory here, an acid, when an acid donates a proton, it forms a conjugate base. Right? Why when a base accept a proton, it forms a conjugate acid. So now, if for example here we have, let's take a proper example of what weak acid now, like acetic acid, CH3COOH. This is called acetic acid, we call ethanoic acid. Ethanoic what acid? This is that. Now, when ethanoic acid loses hydrogen, do you understand? Because it's bosuloic acid. When it loses hydrogen, what you going to form CH3COO minus. Idea. This is called conjugate base of this one here. Conjugate base. Conjugate base. It's called what conjugate what base. So now, if you should add sodium or a metal to it, like Na plus, right there. These are called conjugate salts. So conjugate base and conjugate salt are used interchangeably. Just like you can say conjugate salt, conjugate base. You can say that acidic acid, the acidic buffer solutions, these are solutions that combine a weak acid and its conjugate salts or conjugate base, whichever one you want to try, right? So now, so when you add two of them into a solution, right? Then when you add two of them into solution, CH3COOH plus CH3COONA. This is called acidic buffer. Just so a weak acid and its conjugate salt is called acidic buffers. Do you understand? And what here is that what you want to understand what in buffer solution is that all buffer solution contain acid and base. So they contain H plus and what? OH minus. Right there. They always contain this one here. So a buffer solution will contain an acid and also contain what? A base. So it is saying that the main reason why there is this change in pH, or why there is no significant change in pH when you add acid or base. If, for example, now if you should add acid to a base, do you understand? You activate the if you add acid to a buffer solution. If, for example, now you add acid to a buffer solution, now that acid will react with what? With the base of the buffer solution by neutralizing the effects. On the other hand, if you add a base to a buffer solution, now that the acid part of that buffer solution is going to react with the base, thereby neutralizing what? The OH that is added to it. So that is why there is no significant change in pH when small amount of acid or base are added to it. Just few, just small. Do you understand? So this is called acid buffer. Now we have many of them here, but we have to use this one here. So acid buffer. So acid buffer, these are buffer solutions that contain a weak acid and its conjugate salt. So any weak acid at all and its conjugate salt form acid buffer when you add them together. Do you understand? So the next one to look at is called basic buffer. Basic buffer. So here we have basic buffer. Now, what do you understand by a basic buffer? The word base, that is a weak base and its conjugate acid. Do you understand? So a buffer solution is formed or produced when you combine a weak base and its conjugate salt or conjugate acid. Remember, in postulate theory, when a base accepts a proton, it forms a conjugate acid, right? So that conjugate acid here can also become conjugate salt. So a good example is what is ammonia, NH3. Now remember, when ammonia accepts a proton from the acid, now going to form ammonium ion. Can you see that? So this is the base, the conjugate base, the conjugate acid of this base is what? Ammonium. This is that. Now, if you should add a chlorine here, so we're going to form conjugate salts. So it is saying that can either be a conjugate salt or conjugate acid. Very important. So when we talk about a basic buffer, it's what? Weak acid, weak base plus what? Conjugate salt. A good example is what? NH3 plus what? NH4Cl. Do you see that? So this is what is the base, weak base. This is what is conjugate salt. Two of them are called, when you combine two of them, they are called basic what? Buffer. Do you understand? So a basic buffer contains H plus and OH what? This is what you want to do. So when you add an acid to a base, to a buffer solution, when you add an acid to a buffer solution, it's going to react with the base. When you add a base to a buffer solution, it's going to react with the acid. So the base and the acid will neutralize the effect of anything you add to it. So that's why there is no change in buffer solution, or why there is no significant change in buffer solution. That's why buffer solution resists change in pH when you add small amount of acid to it. Do you understand? So now you now got the idea of what we call basic buffer and what acid buffer, right? So the next one to know here, the next thing you want to look at is what? How do you calculate the pH of a buffer solution? How to calculate what the pH of a buffer solution? This is where you now use the Henderson-Hasselbalch equation. So yeah, the formula used in calculating the pH of for buffer solution is a very special formula. And it's what is derived, because a buffer solution contains an acid and its conjugate base. So two of them must be involved in the calculation. So if, for example, here we have HA. Now let's say HA is acid, right? Now plus water H2O here. So according to postulate theory here, this one is the acid, this one is the base. This is that. Now this acid will donate a proton to this guy here. Now once one accept the proton here, it now become H3O plus aqueous. Remember, this one is an aqueous. This is what? Liquid, right? plus. Now this guy have what? This guy have lost the proton, so we're going to form what? A what? Minus aqueous. This is that. Now, so this is the weak acid. Weak acid. Now, this one is what? Conjugate acid. Here we have conjugate base. Conjugate what? Base. This is that. So when this is what you want to understand here. When an acid lose a proton, it forms a conjugate base. When a base accepts a proton, form a conjugate what? Acid. So yeah, what is happening at the base? Remember, this one is a weak acid. Now, what you want to understand here is that all weak acids have their Ka, which is called ionization constant. Acid ionization constant. So here we have Ka. So I want to write the Ka of this expression here. This is what? The law of mass action. You get? So my Ka is equals to what? Concentration of what? H3O plus. Then times concentration of A minus, which is what? The conjugate base. Over what? Concentration of the acid. This is where you now derive the Henderson-Hasselbalch equation. But I'm not going to derive the Henderson-Hasselbalch equation here, because you use the Henderson-Hasselbalch equation to calculate the pH of what? Of a pH of a buffer solution, either acid buffer or basic buffer. So Ka equals to what? This one here. From here now, you are going to derive the Henderson-Hasselbalch equation. Like when I say, I'm not deriving the Henderson-Hasselbalch equation. So here we have Henderson-Hasselbalch what equation? I don't know if I spell it correctly. So it is the Henderson-Hasselbalch equation used to calculate what the pH of what? Of a buffer solution, which is pH is equals to what? pKa plus log concentration of A minus over what? HA. This is that. So this is the pH here, where pKa is equals to what? Minus